Okay, so this is another Solow-Swan problem. So we have two situations. We have our situation when labor income is saved, and we have our situation when physical income is saved, okay? So, this is our consumption per capita when our labor income is saved, and this is our consumption per capita when physical income is saved, okay? So which case is higher? It's going to be an inequality. How do we get from this line to this line, okay? Because this is the line you kind of want to be at. I mean, not really. You kind of want to go one line further and make everything just 1 less 2 epsilon, 1 less epsilon, 1 less 2 epsilon, right? Because you can just get rid of the division and it makes it really easy to see what is going on here. And remember, epsilon is in between 0 and 1. That's important. It's a parameter, okay? It's in between 0 and 1. Okay? So, how do you get to this line though, okay? You might be a little confused. I don't blame you. You divide both sides. My shadow's kind of in the way here. My lighting's not great. 1 less epsilon times epsilon 1 less epsilon over epsilon divided by 1 less epsilon epsilon. You divide both sides by 1 less epsilon epsilon, okay? Because the 1 less epsilon cancels out and you're left with epsilon over epsilon, which is great because it's like saying epsilon 1 less epsilon over epsilon less 1. And this less 1 is like saying less epsilon over epsilon, because that's 1, which is like saying, because look, we have less epsilon here already, so it works out great. It's just epsilon 1 less 2 epsilon over epsilon. Okay? And then that's when you get rid of the bottom on either side. And then you have these rules where am I geeking out? Sorry, give me one sec. I'm losing it. Okay. This is close to being correct. Why did I can't believe I did this. Okay, so there's two cases. There are two cases. If 1 less 2 epsilon is greater than 0, then epsilon is less than 1 less epsilon. Okay? If that isn't the case, if 1 less 2 epsilon is less than 0, then it's the other way around. So it depends. There isn't just one answer. It depends on the epsilon. It depends on the power of the epsilon, okay? Because we're being asked here, what is bigger? See, our consumption per capita when labor income is saved or when physical income is saved, okay? If this is the case, then we consume more when physical income is saved, because epsilon is less than 1 less epsilon. So this is smaller than this, okay? But when that's not the case, because this epsilon is a parameter, okay? So it fluctuates. Well, if it's less than 0, then this is greater. Then epsilon is greater than 1 less epsilon, okay? So, but I hope that made sense, how we got there. We used a little bit of our math. And now we are done with the Solow-Swan model for the time being. We're going to move on to more game theory, and then we're probably going to do some econometrics as well. I haven't touched much on that, but I'm quite excited.